Okay, so moving on to this page, we're going to go over parallel and perpendicular lines. So parallel lines are two lines that don't intersect and have the same slope. Right, so here in this diagram, I have a picture of two parallel lines. So you can see that they don't touch each other and they're both going in the same direction. Right, so because they're going in exactly the same direction, they'll have the same slope, but different y-intercepts. Okay, so and then the other type of lines are perpendicular lines. And perpendicular lines are two lines that intersect and form 90-degree angles. So the way we can identify perpendicular lines is that their slopes are negative reciprocals of each other. Right, so what that means is that, say you have some fraction as the slope, right? So like a over b. Then negative just means it's the opposite sign, right? So if the original is negative, then the other one would be the opposite sign. And then reciprocal means the denominator becomes the numerator and the numerator becomes the denominator. So you switch the top and the bottom. Okay, so let's look at some examples. So in the examples at the bottom of this page, we have the equation for a given line. And part A wants you to find a line that's parallel to it, and part B asks you to find a line that's perpendicular to it. Okay, so let's do part A first, right? So part A is asking for a parallel line, and so we know a parallel line has to have the same slope. Okay, so in the given line, right, so the form of the line is y equals mx plus b, right? So where m is the slope, right? So the slope of this line is -1/2, right? So parallel means same slope. So that means that the slope of my new line should also be -1/2. Okay. So we have one piece of the information, and the other piece of the information is we need a point on the line, which is given to us in the problem with the x-coordinate being 6 and the y-coordinate being -2. Okay, so now we can use the point slope formula. Which is y minus y0 is equal to m times x minus x0. Right, so if we use this formula, what do we get? So just plugging in the numbers, right? So y0 is -2, m is -1/2, and x0 is 6. And so now let's simplify this, right? So minus 2 becomes a +2 here, and then we distribute the -1/2, so it's -1/2 x. -1/2 times -6 becomes a +3, so +3, and then I subtract 2 from both sides to cancel this out, and then what do I get left over? Y is equal to -1/2 x plus 1. Okay, so you can see that my parallel line has the same slope as the original line, but a different y-intercept. So it's not the exact same line. It's parallel to it. Okay, so we can check the answer at the bottom of the page. And so continuing to part B, we want to do something similar, except now the line is perpendicular, right? So the original slope is -1/2, right? So what I need is the negative reciprocal, which means I take the opposite sign. So the original is negative, so the new is positive, and I have to flip it upside down, right? So the 2 goes in the numerator, 1 goes in the denominator, So here the slope is just 2. Okay, so then I use the point slope formula again, right? So just plugging in the numbers, my new point is a different point. So the x coordinate is 1, the y coordinate is 3. So let me write it here. So y minus y0 is 3 is equal to m. My new slope is 2. X minus x0 is 1. And now I can just simplify this. So I get y minus 3 is equal to 2x minus 2. Add 3 to both sides to cancel this out. And then what do I have at the end? So y is equal to 2x plus 1. Okay, so again, the main idea is that parallel lines have the same slope, and then perpendicular lines have slopes that are negative reciprocals to each other. And then we can just use the point slope formula to write down the equation of the line.